So let's do this. Let's actually generate movie similarities based on 1 million user movie ratings and do it for reals. So just follow along here and I'll show you how it works using Amazon's Elastic MapReduce service. Now to get things set up, I've already loaded some stuff into Amazon's S3 service, which is basically a distributed file store that you rent space on, right? So kind of like HDFS, but it's the Amazon version of it, one way to think about it. So I've already created what's called a bucket in S3 called sundog-spark, and I've uploaded a few things I'm going to need. One is the movie similarities 1m.jar file, and this is the same thing that I generated using SBT earlier in the course. I just gave it a slightly different file name. So that is my self-contained Spark driver script bundled up into a jar file. Okay, so that's going to be on S3, so I can quickly copy it onto my cluster once I've spun up my cluster to run it on. The other thing I've done is I've moved the Movie Lens 1 million rating dataset in here as well. So I've created a ml-1m folder here on my Sundog-Spark S3 bucket, and that's going to make sure that this distributed file system of S3 that contains my 1 million movie ratings is also accessible to my entire cluster. And inside that we have the different files that make up that dataset. Ratings.dat is the actual movie ratings themselves, and movies.dat is all the metadata associated with the actual movies. So our strategy, if you recall, is going to be to run that jar file from the master node of our cluster, and it's going to have movies.dat located alongside it so it can actually build up that lookup table of movie IDs to movie names when it's outputting the results. But all the cluster needs is the ratings data. So let's go and set things up, make a cluster. What you're going to do is go to aws.amazon.com, just like this. And if you don't have an account already, you would create one, obviously, but I already have one, so I'm just going to sign into the console. And remember, too, this is real money we're spending here now, so don't do this yourself unless you're comfortable with that. All right, once we get into the console here, we're going to select EMR, the Managed Hadoop Framework. And even though it says Hadoop and MapReduce, it also has Spark as part of it. So that's going to be our target here. We want to create a cluster. And we'll call it, I don't know, Movie Sims 1M Test. How about that? Now logging, if you want to actually put the log somewhere so you can diagnose what went wrong if something goes wrong, you can do that too. You'd want to keep track of that path so you could actually retrieve those logs in the event of a failure. I'm just going to turn that off because I happen to know this script works. And the other thing we need to do is select Spark for the actual software configuration. So we're going to run with Spark 1.6.2. on Hadoop 2.7 Yarn. So cool stuff. And we are just going to stick with the default hardware configuration. So if you wanted to use different instance types, which have different hardware capabilities, different amounts of memory, CPU power, and whatever, you can do that there and select how many you want to use. I know 3 is more than enough for what I'm doing, so I'll just leave that at 3. Keep in mind this makes a big impact on how much this job costs. So you are charged by the instance hour, and there are different rates for different classes of hardware. So the more beefy computers you use, the more they cost, and it can get expensive pretty quickly. Now, you need some way of actually connecting to your nodes once you create them, and to do that you need an EC2 key pair, and this will give you a private key and a public key you can use to log into these instances once they're created. Now, I already have one, so I'm going to use my Sundog EC2 key pair, but if I need to make a new one, just click on this little link here and it will tell you how to do it. So basically, if you go to the EC2 console, back from the Amazon AWS console, you'll see an option there for key pairs where you can create a new key pair. You create one, and what it will give you back is a PEM file. And down here, it actually tells you the further steps you have to do to convert that into a PPK file that can be used on Windows under PuTTY. If you're using Mac or Linux, then you can follow these instructions instead and just use the PEM file they give you directly. But for PuTTY, there is one additional step where you need to actually run a utility called PuTTYGen to convert the PEM file that you get back from Amazon into the PPK file that PuTTY expects. So just follow these instructions and you can get the credentials that you need to log in. And once you've created that key pair and save that PPK file somewhere safe where you're not going to lose it because there's no way to get it back after you've gotten that initial download, you can just specify that in the drop down here. Okay, so moving on. I've got everything set up properly. I'm going to go ahead and create the cluster. And it'll take about, 10 or 15 minutes for Amazon to actually go out there and find some available hardware and get it all spun up and configured and booted up for you. So we're going to sit here, and you can see right now it says it's in the process of provisioning one master node and two core nodes for our cluster that we're going to run our job on. And through the magic of video editing, we will come back when that's done. So hang on. Okay, so after about 5 or 10 minutes, we see that we now have our master and core machines in the running state here, and my cluster is just waiting for me to do something. So cool, my cluster is ready. So let's do something with it. To do that, first I need to connect to it somehow. So you can see here, under the master public DNS, it gives me the externally available address of the master node that I'm going to run my script from. And if I click on this SSH link, it will tell you exactly how to connect to it. So for Windows, you can use something called like PuTTY for a terminal program. That's what I'm using. And if you need to install it, there's a handy dandy download link there for you. And it tells you exactly how to connect using that. If you're on Mac or Linux, they have instructions for you as well. But I am on Windows, so what we're going to do is copy that address so I can quickly get it in there. And open up PuTTY. Type that in for the host name. And then I need to specify my PPK file, my private key, to actually log into that. So remember, I specified while I was setting up the cluster that I was going to use the Sundog EC2 key, and that's where I saved that file there. So now I should be able to just hit open, and there we are, logged into our master node. Now, depending on your security settings, you might actually get a timeout at this point. So if you're trying to figure out why you can't connect, and no matter what you try with your firewall settings or whatever, you still can't get through, odds are it's blocked on the server side. So if you do run into that, quick tip, you can click on the security group here for the master node. And once you're in there, you can click on the inbound rules here and make sure you have an SSH port open. So in this case, I had to actually manually add a SSH TCP port to port 22 to the IP address that I'm connecting from. So if you are having trouble connecting, that's probably what you need to do. But let's go back to where we were, back to the EMR console. And anyway, we are now logged in, so now we can start doing some fun stuff. So first things first, let's see where we are. We should have a little home directory here under the Hadoop user. First thing we need to do is copy over our actual driver script in the jar file that we created using SBT earlier. So let's go ahead and copy that over from S3. EMR, any AWS EC2 node has a set of utilities built in called AWS that you can use to actually copy stuff from S3 and other stuff. So I can type in AWS S3 CP, let's see, S3 colon / sundog dash, I can't type, sundog dash spark. And what did I call the file again? Movie similarities 1m.jar. Movie similarities 1m.jar here. Alright, and you can see that worked. The other thing I need is the movies.dat file so I can actually construct the lookup table of movie IDs to movie names. And again, I put that in the ml-1m subfolder. So let's copy that over as well. AWS S3 copy S3 colon / sundog dash spark / ml-1m / movies.dat to the local directory. So there we have it. Alright, I've expanded the window a little bit here so we can see our results better, and all I need to do now is type in spark-submit, the name of the jar file, movie similarities 1m.jar. And if you remember right, this script requires a command line parameter of the movie ID we're interested in finding similarities for. So I happen to know that Star Wars is 260 in the 1 million data set. Let's kick it off. Alright, so we see a few introductory info messages here, and one of the first things the script does is turn off anything but error messages. So we shouldn't see anything else other than progress messages as it actually breaks this up and spreads it out to the cluster. So we're basically waiting for it to get that first action command and create the DAG. It just loaded the movie names and it is now spreading it out. So right now, as we speak, we are actually computing similar movies for Star Wars using 1 million ratings on a little cluster of 3 machines. Pretty cool stuff. We're already in stage 2. Now remember, the stages are broken up by areas of the DAG that are split up by data shuffle operations. And those stages in turn are broken up into tasks. So you can see right now here in stage 2, we're chugging through 32 tasks. There'll be another stage after this with 100 for the 100 partitions that we set up. And in about 5 minutes or so, this will be done. It doesn't take all that long, kind of the power of a cluster. Chugging through 1,000,000 ratings in every possible permutation of every possible pair of movies and then filtering out the results we want. It's doing a lot of work, but it will do it fairly quickly. So let's come back in 5 minutes here and I'll show you the results. All right, we're almost done here. There it is. Awesome. So we have the top similar movies for Star Wars Episode 4 A New Hope based on 1,000,000 real movie ratings, and this data set's a little bit newer from 2003, so again, we're not going to see any current movies, but the results look pretty darn reasonable. We have Star Wars Episode 5 Empire Strikes Back, Raiders of the Lost Ark, Return of the Jedi. Kind of interesting that Raiders of the Lost Ark was rated higher than Return of the Jedi, but to be honest, I think I might have enjoyed Raiders of the Lost Ark more than Return of the Jedi, so that maybe isn't as crazy as it sounds. And the original Indiana Jones movie, all very good recommendations for someone who enjoyed Star Wars. And then we start getting into other big movies that were good. The Terminator, Matrix, there's some pretty good ones in here. Back to the Future, Princess Bride, all appeals to sort of that geeky demographic, huh? Very cool. Hey, Monty Python and the Holy Grail even. These are actually pretty darn reasonable recommendations. Cool, and there you have it. So that's movie recommendations, similar movies to Star Wars, using 1,000,000 movie ratings, run on an actual cluster using Hadoop, Yarn, and Apache Spark. That's what it's all about. Now, last step. Do not forget to terminate the cluster when you're done. So I'm going to exit out of this, but that's not enough. And I need to go back to the EMR dashboard. And in my cluster, hit terminate. Yes, I'm sure I'm done with it. Now, if you don't do that, the bill's going to keep on running for you. You know, that cluster is still running, and even though you're not doing anything with it, you're still going to be billed for the time on that cluster for that all 3 of those computers, or even more if you set up more. So again, if you're doing this on your own dime and actually following along, please remember to terminate your cluster when you're done. I really don't want to hear about it if you get a bill for $1,000 at the end of the month from Amazon, okay, as opposed to 10, which is about what this cost. All right, make sure that that terminates successfully, and then it's safe to close out of it. But with that, woohoo, congratulations. That's kind of the culmination of what we've been doing here. We actually ran a real big Spark, big data job on a real cluster successfully and got some really useful results out of it. So cool stuff. Let's talk in a little bit more depth about troubleshooting Spark jobs and some of the finer points of running and tuning things.